nodal analysis problem. So we just did a nodal analysis problem, a very simple one that had one node equation. This one will have, you have as many nodes as you have one fewer node equation when you're doing a nodal analysis problem. You will hear me say nodal analysis, and the person I learned circuits from, what did he call it? Node voltage? I don't know, but you'll hear me say different things, but I mean the same thing whenever I do it. So when I look at this circuit, and I'm going to do nodal analysis, I have to decide what I want to be ground, and then I need to label all of my other nodes either with a variable or with their actual value if I know what it is. Unless I have some reason not to, that I see that something else will make it easier, I'm probably going to make the bottom ground. So I'll make that one ground, and then I'll call this one V1, and this one V2, and this one V3. Now this particular circuit is drawn nicely for you. It has little dots to show you where all the nodes are, but you need to be able to find them even if they're not drawn. Anything that is connected without an element in between it is all the same voltage and is all the same node. So if we look right here, all of this that I just highlighted in yellow, all of that is connected without any element in there, and so that's all the same voltage, and so I can call it all the same voltage. I can call it V3. It's all one node. Similarly, this bottom part, all of this, all of that, that's all one node. But right here in the middle, that we get as soon as we go down, we get to a resistor. We go up, we have a current source, and to the left we have another resistor. So I mean that, that point right there, that's pretty much all you've got for V2. Okay, so now I'm going to write my node equations, and I'll start with V1. So I write all of my currents as coming out from the node. So if there's a resistor, I will do beginning voltage minus ending voltage over resistance. If there's a current source, it'll be negative if it's coming in, and it'll be positive if it's going out. I add all those currents together to get 0, and that's my equation for that node. So this first node will be, I'll start by going up, and so that would be V1 minus the voltage on the other side is V3 over this resistance is 1 ohm. So I got that one. Now I'll go to the right. That would be V1 minus V2 over 5. And then going down, I have a current source. That current source is pointing into the node, so that makes it negative. So minus 1 equals 0. Now I'll do V2. So for V2 going up, I have a 2 amp current source that's coming out of the node, so that'll be positive, plus, now the current going down, I'll do the beginning voltage, which is V2, minus the ending voltage, which is 0 because it's ground, so ground is 0, over the resistance, which is 4, plus V2 going to the left. Beginning voltage is V2, ending voltage is V1 over 5, and that's going to equal 0. And then finally V3. So V3 going to the left, I will have V3 minus V1 over 1. Going down, I'll have negative 2. And going to the right, I have another negative 2. And those equal 0. Now, I want to get these in a slightly nicer format that I can use to make them easier to solve however I'm going to go about solving them. So I like to get rid of fractions. I just don't like fractions. You don't have to. I see that a lot of books do this. I'm going to just write this kind of off on the side. It's not going to be the way I'm going to do it. A lot of books do this by just changing this top one to V1 minus v3 plus 1/5 v1 minus 1/5 v2 minus 1 equals 0. And then when I put these together, I would have 1 plus 1/5 v1 minus 1/5 v2 minus v3 equals 1. And then I don't actually have to end up adding the fractions. I can still use whatever calculating device I'm using, or computer or whatever, and just put that in as 1 plus 1/5 without having to turn it into 6/5. So I can do that. And I see that a lot of books do that, but I don't like fractions. I'm going to make mistakes no matter how I do it, so it doesn't really matter. I do have my notes right here, so hopefully, usually with these I make so many mistakes because there's so much adding and subtracting and so forth, but I'll try to keep an eye on what I've already done. So I'll multiply this top one through by 5, and when I do that, I get, and if y'all see me make a mistake, please holler out. So 5v1 minus 5v3 plus v1 minus v2 minus 5 equals 0. And now if I combine like terms on that, I get 6v1 see, did I do this wrong? Oh, I labeled my nodes differently. You see, and this is what happens. In my notes, I made the top one v2 and the bottom one v3. Okay, it's all right. It just means I won't be able to catch my mistakes. Okay, so 6v1 minus v2 minus 5v3 equals 5. Okay, now on the second equation, I'll multiply this one through by 20. And that will give me 40 plus 5v2 plus 4v2 minus 4v1 equals 0. And then gathering like terms, I'll have negative 4v1 plus 9v2 equals negative 40. And then this last one doesn't look like I need to multiply through by anything, so I have minus v1 plus v3 equals 4. And then I just take those equations, and if you have not gotten one of these calculators yet, I do recommend it. I mean, you can also solve equations, systems of equations on your TI-84 if you have one of those, or lots of other calculators. I do love calculators, so if you have a calculator and want to know how to use it, I'd probably love to figure it out. So this one has system solve, and I'll go to 3x3 linear systems, and then just have to put in my coefficients if I can get to them. Okay, so 6, negative 1, negative 5, 5, negative 4, was that a 3? 9, that was a 9. 9, 0, negative 40, negative 1, 0, 1, 4, solve, and I get V1 equals 37, V2 equals 12, and V3 equals 41. So I have V1 equals 37, V2 equals 12, and V3 equals 41. So now let's see what they're asking for. They're asking for VA. So VA, I look at VA, so the plus side is on the V2 side. So VA equals V2 minus V1, or 12 minus 37, which is negative 25. And Noah here wants to say hello. He's just rolling around on the table over here. Okay, do y'all have any questions?